Hey, this is Mr. Janes. In this video, we'll be talking about the area of some basic polygons, rectangles, squares, triangles, trapezoids, and parallelograms. But before we jump into that, first let's talk about what kind of units you should use when you're talking about area. So far, we've used units like centimeters, inches, meters, and miles to measure length. Length is a one-dimensional measurement. So for example, from point A to point B could be a certain number of centimeters. Maybe this is 10 centimeters, right? And again, it's one-dimensional. But when it comes to area, area is the amount of two-dimensional space that something takes up. For example, how much carpet it takes to fill your house, or how much wrapping paper it takes to wrap a present. Any flat, planar kind of figure is going to be two-dimensional. Now, when we were measuring one-dimensional lengths, we basically broke whatever length we were looking at up into units. For example, in this length right here from A to B, we've got 10 centimeter units. But when it comes to two-dimensional area, we're going to break things into unit squares. For example, the area of this rectangle here looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 8 two-dimensional squares. So I would say, if those were square centimeters, that this rectangle is 8 square centimeters. 8 square centimeters. You could also write that as 8 centimeters, with a little 2 up here, squared. So either 8 square centimeters or 8 centimeters squared are perfect ways to describe the area of that two-dimensional figure. Now let's go ahead and actually find the exact area of rectangles, squares, triangles, trapezoids, and parallelograms. Let's do it. Let's start with rectangles and squares. For now, we'll call this the length with an L, and this is the width with a W. Now, how do we find the area of a rectangle or a square? Let me show you a little animation that should help you. Essentially, we're going to take our rectangle and break it into the square units I was talking about before. There's 1 square unit, 2, 3, 4, until we have a full row of W square units for the width. Then we count up. 4W, 5W, up until we have L times W square units. And so the area of any rectangle is length times width. Let's write that down. So the area of any rectangle, A for area, put a little rectangle down here in the subscript. Area of any rectangle is length times width. Now what about a square? Well, a square is a kind of rectangle, so it'll also be length times width. But remember, a square has 4 congruent sides. And so really, the length and the width are the same thing. So I'll put an L there for both of them. And so the area of a square will be length times length, or you could think of that as length squared. Pause the video here and try and find the area of the next 2 rectangles, this here and that there. Pause the video now. The answers will be up in 3, 2, 1. In the first one I have here, it turns out that this rectangle is actually a square. Only one of the sides is given, 5, but because of all these markings right here, it tells me that all 4 sides are congruent. And this bottom side is also 5. So the area will be 5 times 5, or 5 squared, which is 25. Now they didn't say whether it was centimeters or inches or meters, so I wrote U for units, and it should be square units because we're dealing with area. So the final answer is 25 units squared. In the next problem, we have a rectangle. Now it tells me that the base of that rectangle, the width, is 16, but it doesn't tell me what the length is. So how can I figure out what the length is? Well, it does tell me that this diagonal here is 20. Hey, I see a right triangle here. And I know that I can use Pythagorean theorem to find the third side, if I know 2 sides of a right triangle. Since 20 is my longest side, I'll use that as the c, the hypotenuse of Pythagorean theorem. And so I'll have a squared plus 16 squared equals 20 squared. Next, I know that 16 squared is 256, and 20 squared is 400. Next, after subtracting 256 from both sides, I get a squared equals 144. And taking a square root of both sides, I get that a equals 12. And so this missing side right here, I now know is 12. Now that I've got both the width and the length of this rectangle, I can multiply 16 times 12 to get 192 square units. Next up, triangles. And before we get to the area, we need to talk about two vocabulary words first, the base and the height. Now, the base of a triangle is the length of any one side of a triangle. It doesn't have to be the bottom like I have here. It could have been any of the sides. I just chose the bottom for this demonstration. Now, the height of a triangle is a little trickier. The height of a triangle is the length that connects the base to the height with a perpendicular line. In the first example, this height is already perpendicular or at a right angle to the base, and so the length of that side will be the height. In the second example, though, none of the sides are perpendicular to the base. That means the height of the triangle will drop straight through the center to be perpendicular to the base, and remember, it has to touch that other vertex. The last triangle here is also kind of tricky, because to draw the height on this triangle, we'll have to go on the outside of the triangle. The only way to draw a height in that triangle is to draw on the outside of the triangle, like you see right here. Now that we understand what the base and the height of a triangle are, how do we find the area of a triangle? So we start with the triangle, and now consider two copies of the triangle. So we're going to kind of rotate that triangle and then translate it up until we create a parallelogram. Now that figure right there has double the area of our triangle, and it's also the area of a parallelogram now. Now we know from before the area of a parallelogram is base times height. Since there are two triangles there, that must mean the area of a triangle is 1/2 base times height. So the area of any triangle is going to be 1/2 the base times the height. Another way people sometimes write this is base times height divided by 2. Pause the video here and see if you can find the area of the next 3 triangles. Pause the video now. The answers will be up in 3, 2, 1. In the first triangle, we have the base, which is 7, times the height, which is 4, divided by 2. 7 times 4 is 28, divided by 2 is 14, and again, that is 14 square units. What about the second one? Well, in the second one, 5 is our base, 4 is our height. So we have 5 times 4 divided by 2 leaves us with 10 square units. Now you might have been tempted to use the 7 here, but the 7 is not the base of this triangle. Remember, the base is just the length of one side, and 7 is longer than the length of that side, so we're not going to end up using that in this problem. What about the last one? Well, in this one, we're given that the height is 6, but we don't know what the base is. It's not given to us. 10 can't be the base because 10 is not perpendicular to the height. 6 and this base are perpendicular, not the 10. But we could use the 10 to figure out what the base was with a little bit of Pythagorean theorem. Since 10 is the longest side, the hypotenuse will have 6 squared plus b squared equals 10 squared. We know that 6 squared is 36 and 10 squared is 100. Subtracting 36 from 100 leaves us with b squared equals 64. And the square root of 64 is 8, which means that the base of this triangle is now 8. Now that we know the base, we can find the area. And remember, area is base 8 times the height 6 divided by 2. And 8 times 6 divided by 2 leaves us with 24 square units. Now, if you ever forget the area of a triangle, how to find it, you can always think this. A triangle is 1/2 of a rectangle or 1/2 of a parallelogram. And we know the area of any parallelogram or rectangle is length times width, which is really base times height. And so a triangle will be half of that, so 1/2 the base times the height. Next, let's take a look at parallelograms and trapezoids. A couple of vocabulary words we're going to need for this. In here, the base of a parallelogram is going to be any of the sides, perhaps this one, and the height is going to be the distance perpendicular from that side to the other side. So it's not going to be this part over here. This is not the height, right? That will be called the slant height. The true height of any parallelogram is going to be this distance right there, again, perpendicular to the base. Now, how do we find the area of a parallelogram if we know what the base and the height are? If you start with a parallelogram like this and draw a line in there, an altitude, to cut off that triangle on the end, we can actually translate that triangle over, or slide it over, to basically create a rectangle. Now there's the base and height we talked about before, and the area of a rectangle is base times height. So since we haven't changed the area of the parallelogram is also base times height. So again, because we could cut off this little triangle and bring it over here, like that, okay, the area of a parallelogram is going to be base times height, just like a rectangle. As long as you remember, we're not using the slant height, we're using this height perpendicular to the base. What about a trapezoid? Well, for a trapezoid, we'll need the same definitions of base and height. Here's our base, and here's our height. Again, it's perpendicular to that base, and make sure you're not using the slant height for that. In addition, we'll also need the length of the other base up here. Let's call one of these bases base 1, the other base number 2. Now that we know where the bases, base 1 and base 2, and the height are, how do we go about finding the area? So we start with the trapezoid, and just like the triangle, we're going to take 2 copies of that trapezoid. Now once we put them together, we've got double the area of a trapezoid, and that looks just like the area of a parallelogram. Except now, the base of the parallelogram is super long. It's the length of base 1 plus base 2, kind of the top and bottom base. The area is base 1 plus base 2 times the height, right? Base times height. But since we're dealing with only half of that, we'll have to take half base 1 plus base 2 times the height. In other words, that's the average of the bases times the height. So the area of any trapezoid is base 1 plus base 2 divided by 2, and that number times the height. Now, why do we call that an average? Well, remember, an average is when we add a variety of numbers together and divide by the number that we have. In this case, we add the 2 bases together and divided by 2, the number of bases we had, to find kind of the average length of the base. Then we multiplied it by the height. Pause the video here and try and find the area of the next parallelogram and the final trapezoid. The answers will be up in 3, 2, 1. For the parallelogram, we had a base of 9 and a height of 4. So 4 times 9, that is 36 square units. What about the trapezoid? Let's see. Base 1 is 4 and base 2 is 8, or vice versa. So we have 8 plus 4 divided by 2, and then times the height, which is 6, right there. Again, the height might be outside of the trapezoid, just like a triangle, but remember, it's got to be perpendicular to the 2 bases. So for example, this height and this height, those are called slant heights and will not be used in this problem. Anyway, back to the arithmetic. We have 8 plus 4 divided by 2. Let's see, 8 plus 4 is 12, divided by 2 is 6. So it leaves us with 6 times 6, which is 36 square units. So even though these 2 figures look completely different, they had the same area. That's it for the area of basic polygons. Next what we'll be doing is trying to find the area of more complex polygons. But even though these look a lot more involved than the other ones, they're actually not so bad. The key will be to break up each of these more complex polygons into shapes we already know, things like triangles, rectangles, squares, trapezoids, and parallelograms. And there's usually more than one way to do it, which means there's multiple ways to get to the same answer. But we'll save that for later.